Good afternoon, OCP. Hey, come on, give me some love here. Make some noise. Oh, wow. Standing here is a bit intimidating, you know. So I have a beer before I come up here, so I feel feeling pretty loose right now. So I talked to some of my friends. I say, this is time that you prove whether you have friends or not. And I am lucky. Look at this. You know, this is a full house. So thank you, guys. Okay, good afternoon. It has been a privilege to be here at OCP 2025. My name is Simon Ong. I'm representing LION Technology. And today I'm here to share with you on the topic pertaining to ultra-dense AI clusters. And I'd like to share with you what LION has to offer in the ultra-dense AI cluster solution, and why we think 800 VDC is the path to go. And we'll share with you the LION integrated solution for power and liquid cooling to support and enable this new architecture. Is this moving? Oh, okay. Oh, it's moving now. So in recent year, we see the adoption of the first GPU for large format AI application, and that formed the foundation for AI cluster moving forward. And you know, last year, we see that with the increase of the computing power, the power requirement to support the AI cluster increased by 100%, and the weight increased by 50%, and then we see that direct liquid cooling become an essential requirement in AI application. And moving forward into 2025 and forward, what we see is that the rise of ultra-dense AI clusters, and where the power requirement for a single AI rack now grow 10x, almost 10x, 8x, to 1 megawatt to 1.2 megawatt. And that really is a key game changer. And with that change, we also see that the payload per rack has increased 300%. And now the entire AI rack is liquid cooled. So that is the situation that we are facing, and that's the challenge that we have to go resolve to support this new concept. In the past, I think for current generation AI cluster, we are using 48-volt distribution within the rack. We're happy with that totally great solution. But imagine now the existing rack is about 120 kilowatt, and it's going to be escalated to 1 megawatt to 1.2 megawatt. The power actually go up 8x. And it has really surpassed the potential or the possibility of physics to do 448-volt distribution within the rack, because now the bus bar grow like 8 times. You know, and imagine that the copper loss, if that happened. And also there's no way that we can really kind of effectively cool that bus bar. So what will be the solution? The solution will be an 800-volt DC. By going to 800-volt DC, we effectively reduce the current transmission by 16 times. And then now you see the bus bar go down and even thinner, and make everything possible. And of course, by going to a higher voltage distribution, we have a lower copper loss, a low transmission loss, which also resulted in a higher efficiency solution. But again, like all things, you know, the 800-volt DC solution doesn't come without challenges. The first challenge we're going to face, of course, is the safety requirement of transmitting high voltage DC. And they have to be well protected in order for us to be able to use it safely. So the safety protocol for 800 volt DC distribution become a very key component and a challenge that we have to go resolve. And not only that, now we have to have a new converter to support this architecture. And with that, we'll need help from our good friends in the semiconductor space. And new semiconductor devices will have to be invented to support this new architecture. At the same time, now imagine that we have 1 megawatt in one single AI rack. The complexity of thermal management become very important and very critical. And we see there are more challenges in achieving that goal. And last but not least, how do we scale? Within our company, we always talk about, now we're going to produce a megawatt power rack. But the next thing, how are we going to do burn-in? How are we going to do testing? Imagine that we have to ship 100 power rack with each of them carry more than 1 megawatt of power. Just think about having to do a burn-in is a big headache for all of us. So really the challenge about scaling and scaling at a high reliability solution is our most critical challenges for us in terms of producing the solution to the market. So at Lite-On, we are committed to deliver the most reliable, highest quality product to support and enable the ultra-dense AI cluster. The ultra-dense AI cluster not only bring performance to the AI application, but it also bring the highest demand on performance plus pressure. What kind of pressure we are facing? Okay, the greater pressure on coming out with a high efficiency solution, the greater pressure of coming out with a more effective thermal management system, and last but not least, a greater pressure of coming out with a greater and more effective integrated solution. So with that, Lite-On has involved in getting a total solution and integrated solution ready to support the ultra-dense AI cluster. And with that, I introduce to you our total solution for this next generation AI cluster. It features a high efficient 800 volt DC 1 megawatt power rack that is up to 4 to 3 redundancy. And it also allows the user to do maintenance and upgrading from the front panel. And not only that, you also feature a lot of safety from the AC bus to the DC bus, because now we're trying to transmit 800 volt DC. At the same time, you also support a very rugged as well as ultra durable rack that support the 300% increase in payload. Now every rack is more than 3,000 kg. And last but not least, a totally integrated approach of a new thermal solution that's precisely controlling the thermal requirement and by cooling the rack effectively, precisely with a microcontrol system. There's a lot of things that we are doing to enable this solution. Just to quote you a few examples, first and foremost, we talk about the safety of distributing DC bus, a high voltage DC bus in a system. So we have incorporated the safety protection device into our busway so that we ensure that we are meeting all the compliance requirements for safety in distributing the 800 volt DC. At the same time, we have designed a ultra durable, high density rack that has carried 3,500 kilograms of payload in this new IT rack. And last but not least, we have a latest and greatest 2.1 megawatts thermal management direct liquid cooling solution that feature 3+1 independent pumps that can be hot swapped for service, for repair, without compromising the operation of the AI clusters. So those are the great things that we are doing to support the ultra-dense AI rack. So to recap, some of the benefit for 800 volt DC distribution, and by using that architecture, we not only can achieve a higher efficiency in the AI rack, and by incorporating a highly precision cooling solution, we are able to reduce the power waste as well as lower the carbon emission of the entire solution. And that translates to a higher sustainability solution overall to support the AI application. So having said all that, I would like to show you a short video clip, slightly more than a minute, and that kind of sums up everything I've just said in the last 10 minutes. Can you play the video? There's no audio. I think we have a technical glitch here. We have our branding team has done a great job on this video with very good music. So I think I'm going to make the crews over there to replay the video so that you get to enjoy this as much as I can. So they say not all. Let me hear you. Woo! Thank you. So thank you for your time. Before I go, anyone have any question? Yes, please. Thank you.
Yes, hi, Simon. I'm
Hi.
a big fan, by the way. So I just wanted to ask, when you say 800 volts, you mean plus or minus 400 volts? Or
No,
is it
it's 0 to 800.
plus or minus
0 to 800.
0 to 800?
Yes.
Ah, okay.
Okay.
Okay, very good. Thank you.
Thank you. Any more question? Justin, you want to ask a question? No. All right. I want to see L. Lena, you want to ask a question? Yes? Ask one question. Well, okay, no more question. Well, it seems that I have delivered the message pretty clearly. There's no question. So thanks for coming. If you like, please come scan your badge. My crew is there. After you scan your badge, you get a nice little mark like this. Thank you guys. Appreciate it. Thanks a lot.